More than 15,000 years ago, when the last glaciers of the vast ice sheets that once blanketed the North American continent ended their southward advance in Illinois, massive new landforms and waterways were created, still visible today. In Kane County, Illinois, evidence for these great Ice Age features are conspicuous in the landscape, in the form of Kames, Moraines, vast glacial lakes, and immense open plains. Please join us as we examine the last throes of the Pleistocene Epoch in northern Illinois, Kane County's Ice Age legacy.
Primary sources for this video include The Illinois Glacial Lobe by Frank Leverett, published in 1899. Pleistocene Stratigraphy of Illinois by H.B. Willman and John C. Frye, published by the Illinois State Geological Survey in 1970. Quaternary Geology, Geomorphology, and Climatic History of Kane County, Illinois, by B. Brandon Curry, David A. Grimley, and J. A. Stravers, published by the Illinois State Geological Survey in 1999. Superficial Geology of Kane County, Illinois, by B. Brandon Curry, David A. Grimley, and Allison R. Brugger, published by the Illinois State Geological Survey in 2013.
Looking out over the vast plains of the North American interior, in what is today Kane County, Illinois, observing its general flatness and mild undulating topography, broken by the occasional sedate stream or river, it is difficult to fully comprehend how dynamic this landscape has been over the past 30,000 years or more, in the deep time of geology, Earth's rough-and-tumble daybook, when immense rivers of ice flowed from the north and lay heavy upon the land for as far as the eye could see. This was the Laurentide ice sheet, a sweeping array of glacial lobes, blanketing much of the northern latitudes of North America, extending as far as Carbondale, Illinois, 300 miles to the south, during the Pleistocene Epoch, tens and even hundreds of thousands of years ago. Here, massive ice walls raked the landforms, reshaping them into relatively flat and featureless plains. But the glacial handiwork of these immense ice giants did not stop there.
When the glaciers stagnated and stopped their southward march, they left final footprints in the form of terminal moraines, which were plowed up sediment ridges at the vanguard of their advance. Kane County still bears the jagged scars of several moraines, as the region was something of a parking lot for multiple massive ice lobes that tarried here before shrinking back to the north. The Marengo and Burlington moraines to the northwest, the Elburn complex to the southwest, the St. Charles moraine and the Manuka moraine to the southeast, and remnants of the Berlina and Woodstock moraines in the county's northeast corner, all likely deposited between 16,000 and 30,000 years ago. Every few thousand years, a new massive glacier bloom, an offshoot of the Wisconsin ice sheet, the Ice Age's coda, would descend across northern Illinois and Kane County, then retreat, reform, and start the cycle again, until the vast ice sheet bloomed no more.
Each time the ice sheet stopped, the dead glacier, no longer flowing, became an enormous tract of enduring ice and permafrost. Within these stagnant ice fields, depressions formed, where sediment, sand, and gravel accumulated. As temperatures slowly warmed and the ice melted, these debris-filled ice depressions created great mounds in the landscape, referred to as Kames by geologists. Depressions beneath the ice filled in with water as the ice fields melted, dotting the newly created tundra with lakes and ponds. Geologists refer to these glacial lake features as kettles. Eskers were yet another glacial formation, often a sinuous low ridge, representing the former bed of a river or stream that passed beneath the glacier. Multiple examples of Kane County's Ice Age Kames and kettles can be found at the Freeman-Kame Meager Forest Preserve near Gilbert's, Illinois. And also at Johnson's Mound Forest Preserve, further to the south, where large Ice Age Kames dominate the landscape southeast of Elburn.
Geologists first began understanding and mapping the Pleistocene superficial geology of northern Illinois in the latter part of the 19th century. These scientists included Amos Henry Worthen, Arthur C. Trowbridge, and Frank Leverett, and much of their work survives to this day. Geologists have been fleshing out and refining these early observations and models ever since. Recently, more precise mapping and dating methods and the use of LIDAR, or light detection and ranging, has enabled geologists to discover more subtle ice age features in the landscape, and to thereby create even more precise understanding of the advance and retreat of the glaciers over time.
In the mid-1960s, geologists began to take note of another feature in the Ice Age landscape, hiding in plain sight. At that time, geologist Lee Clayton of the North Dakota Geological Survey began taking core samples of flat-mounded areas in North Dakota in a topography shaped by glaciation. Within the cores, he found fine clay sediments, organic materials, and shells of ancient crustaceans, similar to those found in lake beds, but they were inexplicably sitting sometimes tens of feet higher than the surrounding terrain. How could a lake bed be high above the landscape? What could explain these curious observations?
By studying existing glaciers, Clayton and other geologists soon came to an answer. When glaciers stagnate, coming to a rest, sediments start building on the top surface of the ice sheet from centuries of wind-blown dust. Plants and tundra take root, creating a vegetative mat, the cyclical decay of which contributed to the building sediments. Holes develop in the ice, perhaps from existing crevices, the edges of which melt away. Coarse gravel deposits from the melting ice line the opening of the developing chasm. These holes begin to fill with water from precipitation and the melting permafrost. Life, in the form of aquatic plants, insects, and tiny crustaceans, takes root in these newly formed ponds and lakes, and over centuries, layer upon layer of sediments and organic debris builds upon the lake bottom. The hidden stagnant glacial ice forms the walls of these lakes. As the climate warms, the glacial permafrost eventually melts, including the lake walls, and the lake itself drains away. The lake sediment folds back onto the topsoil surface of the land, the lake bed now standing proud above the surrounding landscape. Lee appropriately named these newly recognized glacial features as ice-walled lake plains.
In the ensuing years, geologists began finding Clayton's ice-walled lake plains sprinkled all throughout the upper U.S. Midwest, in the Dakotas, Minnesota, Wisconsin, Michigan, and even as far south as Illinois, suggesting that this was a widespread phenomenon in the post-glacial environment of North America. LIDAR imaging, invented in the 1960s, began to see widespread use in the 1990s, 2000s, and 2010s, as refinements in the technology significantly reduced the costs necessary to deploy this tool. LIDAR is typically used from an airborne vehicle to systematically bounce laser beams off the Earth's surface, measuring the topography with amazing precision. This precision gave geologists a new tool for examining the superficial geology of the U.S. Midwest landscape, including ice-walled lake plains.
During the last few decades, using LIDAR and sediment coring, Dr. Brandon Curry of the Illinois State Geological Survey has systematically mapped many of the ice-walled lake plains in Illinois. Dr. Curry's research points out that there are at least two concentrations of ice-walled lake plain formations in Illinois, one in Kane and DeKalb counties, and the second arcing through LaSalle, Grundy, and Livingston counties. He notes that they are even more widespread to the north, in Wisconsin and Minnesota.
Examining an aerial LiDAR image of these areas, it almost has the look of a lunar landscape, chock full of impact craters, although these ridged features are actually former ice-walled lakes. And Dr. Curry is quick to point out that the LiDAR images are enhanced to better highlight the superficial aspects. Indeed, if you look at these pronounced LiDAR features on the ground, or from a drone, you will note how remarkably subtle these features are in the landscape, the glacial lake plain being only a few feet higher than the surrounding terrain. In fact, the flatness of these features is one of their defining characteristics, as it represents a former lakebed formed over the span of perhaps hundreds or thousands of years.
The mother of all ice-walled lakes in Kane County is known as Glacial Lake Pingree. This superficial feature was first described in the late 1920s in an unpublished manuscript by geologists Morris Layton, Paul McClintock, and William Powers, although they did not recognize it as an ice-walled lake at that time, but rather as a lake formed from glacial stagnation processes. This large lake was then measured to be more than 13 miles long, north to south, from Huntley in McHenry County to Lily Lake in Kane County, and about 6 miles wide. It was so named as it was roughly centered upon the tiny village of Pingree Grove, then with a population just north of 100 residents, the hamlet straddling the border of Plato and Rutland townships, and several miles west of the Fox River.
Pingree Grove, in turn, was named for the Pingree family, most notably brothers Daniel and Andrew Pingree, who settled this area shortly after Native Americans were forcefully driven from this place into Iowa. Andrew Pingree was a Universalist minister as well as a surveyor, while Daniel Pingree was a renowned local physician. This part of Kane County was attractive to early settlers, as it had rich soils with generally flat terrain, a byproduct of Lake Pingree's ice-walled lake attributes, which made the land most suitable for farming.
The low-lying area that makes up the Pingree Lake Plain is nestled between at least two glacial moraine features, the Marengo Moraine to the west and the Elburn Complex Moraine to the southeast, which includes multiple Kames features. As it sits behind the Marengo Moraine, the Glacial Lake Pingree feature is believed to have been largely the result of the glacial stagnation processes that followed the cessation of the Wisconsin lobe about 24,000 years ago.
If we were to go back in time, perhaps 20,000 years, what would we have seen standing atop the Marengo Moraine, looking out over Lake Pingree? Would we have seen a vast freshwater lake stretching out for miles in every direction? Would we have seen an immense boggy area with occasional open patches of water? Dr. Brandon Curry describes that the landscape would have been quite different than anything we know of today in northeastern Illinois.
The vegetation would have been entirely distinctive, consisting of a mat of Arctic tundra fauna, such as mosses, lichens, and cold-hardy grasses and shrubs. It would have been a treacherous karst terrain, pocketed with sinkholes and crevices, as melt holes and channels opened up in the ice underlying the tundra sediments. Rather than there being one vast lake of open water, Curry envisions it as more of a patchwork of ponds, small lakes, watery marshes, surmounted by an occasional island or ridge, former Kames and Eskers. Indeed, it may have been difficult to discern as one large body of water, as we might imagine it today. Instead, Curry suggests it may have been more akin to the Taimyr Peninsula in present-day northern Russia.
Although Illinois saw many glacial lobes and their resulting terminal moraines come to a rest during the Ice Age, in only a small subset of these arose conditions ideal for the formation of ice-walled lake plains. The Kane-DeKalb ice-walled lake plains appear to be associated with the Marengo and Bloomington moraines from 20 to 24,000 years ago, while the LaSalle-Grundy-Livingston ice-walled lake plains are associated with the Marseilles moraine of roughly 16,000 years before the present. Geologists have yet to determine what factors and conditions might have favored the formation of these Ice Age features.
But a big part of answering this question is related to the precise dating of moraines and their related geomorphic structures. Geologists have been attempting to refine these dates since first describing the Pleistocene features of Illinois in the latter part of the 19th century. Initially, the age of these formations was determined by the analysis of fossils and fauna from the geologic samples, such as shell material, bones, and plant remains. But with the emergence of radiocarbon dating in the 1950s, then later amplified by accelerator mass spectrometry in the late 1970s, and subsequent calibration by dendrochronology, or tree ring data, geologists have been able to derive much more accurate and precise dates for organic specimens obtained from core samples taken from these Ice Age features. This dating has enabled them to create a more precise map of the various glacial movements and recessions that took place during the Pleistocene period, over the past 100,000 years or so, into northern Illinois.
Indeed, Dr. Curry has been studying the ages of the ice-walled lake plain formations astride the Bloomington and Marengo moraines for the past several years. He took an interest when he observed that the Bloomington morainic system appeared to be truncated by the Marengo moraine, suggesting that the glacial lobe that created the Marengo moraine crashed into or intruded into the deposits left behind by the Bloomington moraine, indicating that the Bloomington is older than the Marengo moraine.
Water level in the wetland rises.
To test this hypothesis, Dr. Curry, aided by local amateur geologist David Scheinknecht and geologic core drilling specialists, took more than 100 core samples, roughly 50 feet in depth, from about 40 ice-walled lake plains on both the east and west sides of the Marengo moraine. The idea was that by sampling the ice-walled lake plains on both sides of the moraine, including parts of Lake Pingree, this would help to determine the relative ages of the Bloomington moraine ice-walled lake plains and the Marengo moraine ice-walled lake plains, and hence the moraines themselves.
These core samples were obtained over the course of a few months via the hard work of the Dolans of Black Sheep Geoservices. We were fortunate to spend a day with the Dolans, moving from core site to core site, sometimes in somewhat remote locations, setting up their remotely controlled coring rig, drilling deep into the earth, retrieving, labeling, and storing the samples. Before they were shipped off to Dr. Curry's lab at the University of Illinois at Champaign.
At a geology presentation at the Barbara Building Lodge for the Kane County Forest Preserve District in October of 2022, Dr. Curry demonstrated how the core samples are removed from their plastic jacket. And then analyzed by looking for organic materials, such as parts of plants, from sediments laid down thousands of years ago. The plants that tended to thrive in Kane County's Arctic environment of 20,000 years ago were Dryas intergifolia, or Arctic avens, Salix herbacea, or snowbed willow, and Vaccinium, or Arctic bilberry. These plants had waxy, thick leaves, parts of which have managed to survive in the Ice Age sedimentary ooze many tens of feet below the surface. These leaf fragments, and sometimes small pieces of wood, are then isolated, cleaned, labeled, photographed, refrigerated, and sent off to the Keck Carbon Cycle AMS facility at the University of California at Irvine for radiocarbon dating.
When the results came back from the California lab a few months later, the findings were intriguing. Assessing the measured dates from east and west of the Marengo Moraine, Dr. Curry found that there was no statistically measurable difference between the two sets of data. The dates west of the moraine measured between 15,000 and 21,000 years before the present, most clustered between 19,000 and 21,000 years BP, while dates from the east of the moraine measured between 16,000 and 24,000 years before the present, with greater variance. The results are intriguing as they suggest that the relationship between the terminal moraines and nearby ice-walled lakes is more complex than first thought, at least in the complicated Ice Age landscape of northern Kane County.
Based on these inconclusive results, Dr. Curry now suspects that a new tactic will be required to gauge the relative ages of the Marengo Moraine and Bloomington Moraine by coring deeper into the earth in order to examine the soils, tills, and organic materials that were buried directly beneath the advancing ice sheets of the Pleistocene. Dr. Curry explains that his recent research has been examining the top of the Oreo cookie, which proved inconclusive, but now needs to examine the bottom of the cookie to more directly measure when the creamy filling, the Wisconsinian ice sheets, the last throes of the Ice Age, moved into northern Illinois.
In a lot of places, the glacier buries old surfaces, often organic rich, and I would look at the dates there on either side of the moraine and see if those tell us anything. So we know that the ages in terms of looking at the top layer of Oreo cookie are inconclusive, but maybe on the bottom we could get that difference that would support the geomorphic evidence.
But the analysis of these ice-walled lake plains core samples does not begin and end with the radiocarbon dating results. Indeed, Dr. Curry also examines these core samples for microfossils and organic materials, which provide much information regarding the climate of the end-stage northern Illinois glaciation. For example, one set of microfossils that are often abundant in these core samples includes ostracods, an area of particular expertise for Dr. Curry. Ostracods are a type of tiny crustacean, which have the appearance of shrimp in bivalve shells, as Dr. Curry describes them. The relative population sizes and the types of species found of these tiny creatures are diagnostic of the ambient temperature at the time when the sediments were laid down in the core samples. Not surprisingly, Dr. Curry's ostracod analysis indicates that the temperature when the last of the Illinois glaciers began their retreat back to the north was quite cold, with an average daily temperature of 40 degrees Fahrenheit, or about 4 degrees Celsius, somewhat akin to the climate of Fairbanks, Alaska. But Dr. Curry's findings go even further.
Yeah, I think there are large spans of time when there's absolutely nothing going on in the landscape. It's so cold, there's no organic matter, there's no sediment moving on the landscape. It was like in suspended animation. It was so cold.
As Dr. Curry's research has shown, the post-glacial terrain and environment of northern Illinois and Kane County were far more complex than anyone had initially realized, with Kames, Eskers, Moraines, and ice-walled lake plains peppering the landscape. Indeed, it can be said that the Kames and Kane lay mainly by ice-walled lake plains and their glacial moraines.
I think she's got it. By George, she's got it!
But more seriously, Kane County is rife with Ice Age features that tell a breathtaking story of a very different, dynamic, and harsh environment, far distant in time, but perhaps within human memory, when massive ice sheets, hundreds of feet thick, held sway, carving out the landscape, raising monumental landforms, shifting rivers, and creating immense lakes and outwash basins. As the ice retreated and tundra and spruce forests blanketed the area, gigantic creatures then moved upon the abandoned Pleistocene stage, the Ice Age proboscideans, mammoths, and mastodons. A story for future videos.
Many thanks to Dr. Brandon Curry, David Schoenknecht, and the Kane County Forest Preserves for their tremendous assistance in the production of this video. Thanks also to our Be Historic channel community, our subscribers, our super thanks contributors, and our generous Patreon supporters. As always, if you enjoy these videos, please remember to like, subscribe, comment, and share. And if you are so inclined, consider supporting our channel via Patreon. Thank you for watching, and we'll see you, in a manner of speaking, in our next video adventure.